Hi everyone, in this video we'll be talking about how to determine the formal charge of an atom in a molecule. This method is extremely useful for determining which Lewis structure is the most optimal Lewis structure for a molecule. So what is formal charge? Formal charge is the charge assigned to an atom in a molecule, and the goal is to try to get all of the atom's formal charges as close to zero as possible. This will tell you if you have a good Lewis structure or not. And if you can't get them all as close to zero as possible, what you want to do is give the electronegative atom the most charge. So down here I've drawn a sample Lewis structure, and we're just going to try and determine the formal charge of each atom in this molecule to see if it's a plausible Lewis structure. What is the equation for solving for formal charge? Well, formal charge is equivalent to, and I'm abbreviating it as FC, the total number of valence electrons, and I'll abbreviate electrons as E minus, minus the total number of non-bonding electrons, or the electrons in the lone pairs, minus 1/2 times the total bonding electrons. So let's try and find the formal charge for each atom. We'll start with oxygen. So we'll just go ahead and plug everything into this equation here. Formal charge is equal to, oxygen has 6 valence electrons, and we know that from the periodic table, minus the total non-bonding electrons, so that'll be these electrons present in lone pairs. So we have 4 of those, minus 1/2 times the total bonding electrons. So those will be our atoms present in these bonds right here. And since we have 2 bonds, as it's a double bond, we have 4 bonding electrons, since each singular line drawn represents 2 electrons. So we have 4 bonding electrons in oxygen. We solve this out, we get 6 minus 4 minus 2, and that gives us 0. So we're looking pretty good so far. Next, let's try for nitrogen. And I'll go ahead and erase some of this stuff so we can count better. So nitrogen. We'll start the exact same way. Formal charge is equal to the total number of valence electrons. So for nitrogen, we know from the periodic table that is 5, minus the total non-bonding electrons. You can see that is 2 in our lone pair here above the nitrogen, minus 1/2 times total bonding electrons, and we can see that nitrogen actually has 3 bonds drawn around it, and each one represents 2 electrons, so we know that that's 6 bonding electrons. We solve this out, 5 minus 2 minus 3, and we get 0 again, so still looking pretty good. Let's now solve for chlorine. We'll start with formal charge is equal to, chlorine has 7 valence electrons, minus, we have, let's count up these non-bonding electrons, 2, 4, 6 non-bonding electrons, minus 1/2 times the total number of bonding electrons, and we can see that chlorine only has 1 bond here to its left, which means it has 2 total bonding electrons. So we'll do 7 minus 6 minus 1, and we find that it also has a formal charge of 0. So since all of these numbers came out to 0, we can say that this is a good Lewis structure. So this is a plausible Lewis structure for this molecule.